class, this lecture hopefully will be a little shorter because you all are capable, we've started doing the calculations and walking through the hypothesis testing, so you kind of understand the process. Again, you will need to indicate the 5 steps in hypothesis testing. Step 1 is to state the null and alternative hypothesis. So that's what we're going to look at first. And I'm going to leave you to your own to do the calculations this time. And as you go through, if you need help or want to just make sure you're on the right track, feel free to send me an email, and I'll look at your work and we can kind of talk about where you're at. So the question that we're asking here are the mortality rates from the MSDRG 292 and MSDRG 293 statistically different? So if we pull up our data set to start with, we've already got our mortality rates for all 3 of our DRGs calculated. And what we're going to do is I'm going to copy this and paste it, and we're going to go back and change those value fields back because we need to know how many patients are in each data set. Oops, that kind of shrunk. Okay, so what we're going to need to look at is the mortality rates, and we're comparing 292 to 293. Remember, the last lecture we were comparing the mortality rate of 291 to the U.S. rate. Here we're comparing two proportions that we're not comparing to a standard. We're seeing is there any statistical difference between these 2 proportions. So the information that you're going to need for this formula, here we go. Here are our formulas. Here is our Z formula for our 2-sample Z-test for proportions. And you see we've got a few different proportions. We've got P1, which is our proportion of our variable, our first variable. P2 is going to be our proportion of our second variable, and then we also have a variable P in our formula. We have to calculate P, so the first thing you have to do is do the calculations for P. So let's go through and look to see what information we're going to be plugging in to our formula. So we need proportion number 1, so the percentage of, let's see if I can split this. It might be too hard to see. No. So we're going to kind of overlap this just a little bit and see if we can get this. So our P is equal to 2.08% or 0.0208. P2 is equal to 2.47%, or for our formula, 0.0247. And then we have N one equals, this is going to be right here. Let's pull this over just a little bit. There we go. N1, so our sample size of our first DRG set is 144. And N2 which is our sample size of our second, is 81. So this is all the information that you need to plug in to P. Once you get P calculated, you might want to send me an email and verify that your P is calculated correctly. Once you get P calculated, you should plug in the information that I've just submitted to you right here into your Z statistic along with your P information. Remember, order of operations, biggest parentheses should be calculated first. 1 minus P should be calculated second. Then you should multiply P times whatever this come out to be times whatever this, then take the square root. So you will need to come up with a Z statistic, whatever your Z equals. You need to let me know what that equals. Once you come up with your Z statistic, you will then so again, we're looking at the same table as we did for our last test, and we are looking at the 0.025, and again, that's the 1.960. So what you'll need to come to the conclusion is your Z statistic greater than 1.960 or less than a negative 1.960. If it falls above or below the critical values, you would reject the null hypothesis. Conclude that you would conclude that the rates of the two MSDRGs are not equal if the Z falls within the range, you would not reject the null hypothesis and conclude, oops, that got really small. You would conclude, you would not reject the null hypothesis, and you would conclude that there is no statistical difference between the mortality rates. So if it's more extreme one way or the other than the critical value, you would reject the null hypothesis and conclude that the rates of the two MSDRGs are not equal. If the Z statistic falls within the range, so if it falls between 1.960 and a negative 1.960, you would not reject the null hypothesis, and you would conclude that there is no statistical difference between the mortality rates. So I need to see what your Z statistic turns out to be. And I would suggest before you get to that point, you check with me to make sure you're on the right track. And then once you get your Z statistic, you need to compare it to your critical values and give me your conclusion. If you have any questions with this lecture or anything that I can help you with, if you have some questions and need additional guidance, let me know. I'd be happy to work something out and see if we can get that figured out. There is an example of the Z statistic. And that is the two-sample Z test for proportions. The explanation starts on page 79 in your book. The example is on page 80. What I will tell you about the example is what they've plugged into the formula in step 4 is not correct. And I have given you all the corrections. It's in the second discussion for chapter 4. There's an attachment with the corrections. They have plugged in the incorrect information in those formulas. So be sure that you look at the corrections for example 4.1. And again, if you have any additional questions, be sure to let me know.